Perceptron for AND gate is the question. We'll have a look into this particular video. Hi, welcome to this class. I'm Dr. Jena Prasad. Regarding this perceptron as well as the SLP, there is already a video prepared. Just have a look into the other videos. So in this video, we'll have a look into the exactly how do you represent the perceptron for the AND Boolean gate is. For information, let's have a look into the algorithm for the perceptron. The Frank Rosenblatt suggested this algorithm, and there are 4 steps are involved in doing this algorithm is. The first and foremost, we have to set a threshold value for the given neuron. After setting the threshold value, what are the inputs are there? Multiply all inputs with its weights. For each input, there is a weight would be assigned and multiply all the inputs. So after multiplying all the inputs with weights, sum all the results and that is called sigma. After that, activate the output. So these are the 4 steps involved in the execution of a perceptron is. So a perceptron is often used to classify data into 2 parts. And a perceptron is also known as a linear binary classifier. Let's come to the AND Boolean gate is. And here now, AND Boolean gate, x1, x2 I took, and the y value is the actual value here. And this is the one, we can have a look into this one, x1, x2, and their weight 1, weight 2 are there, and the y value. So the gate returns 1 only if both inputs are true. It returns 1 if both inputs are true. Otherwise, it returns a false only. So 0 and 0, 0, 0 and 1, 0, 1 and 0, 0, 1 and 1, it is 1. So these are x1, x2 values are different cases. Now the weights you should take randomly. Here now the weights of both W1 and W2 have been taken as 0.9. We have, based on the error rate, we need to perform the rounds. The first round, what we are going to do is both x1 is 0 and x2 is 0. x1 is 0 and x2 is 0. So now actual value is y. So this one gives the 0 as a value. This particular perceptron or not will verify it here. Now, according to the algorithm, we are supposed to multiply x1 and x2 values with the weights. So the formula is x1 into w1 plus x2 into w2. So 0 into 0.9 plus 0 into 0.9. 0.9 means it is a weight value. The result is 0. So activation unit checks the sum unit is greater than the threshold value. So what is threshold value we have taken is called 0.5 is the threshold value is taken. Now the rule is satisfied because of is fired, the unit will return 1, otherwise it will 0 here. The rule is satisfied here. So what you got is you got 0. So 0 is less than 0.5. So that's the answer is also 0 and results also 0. So in this case here now the first one, this neuron also, this perceptron also is giving a 0 value. So some unit was 0 for the first instance. So activation unit would return 0 because it is less than a 0.5 value. Similarly, the output should be 0 as well. So we'll not update weights because there is no error in this case. The weights are not required to update. What are the weights have been taken 0.9 and 0.9 are giving the correct answer for us in the first instance. Now we'll go for second instance. x1 is equal to 0 and x2 is equal to 1. The sum unit, if you done same calculation like previous one, the result is coming as 0.9. So the threshold value is 0.5. So 0.9 is greater than 0.5. The result is 1 is coming out. So 1 actually, what is the actual value is 0, and what the output we got is called 1 we got. So here in this case, the error has come. So that's why we need to do some calculations here. So epsilon is equal actual minus prediction value. The value we have, what we have is called actual value is 0, and the results we got is 1. So if you subtracted, the values come as -1 comes out. That means we have to change both weight 1 and weight 2 values we need to change. To change this both weight 1 and weight 2 values, we have to do some calculations to be performed. To do the calculations, what you have is called here, the previous case, what you have is called, the range we have taken is called 0 and 1. Between 0 and 1, the average is 0.5. So the formula is W1 plus alpha into epsilon. So 0.9 is the W1 value, old value, plus 0.5 is the one we got it here between the learning rate value between 0 and 1. So that's why we have taken as 0.5 into minus 1. The answer comes is 0.5 and W2 also 0.4. So now we go for third instance. This will be updated. So now the both W1 value, W2 values are 0.4 and 0.4, not the 0.9 and 0.9. Now we'll apply 0.4 to the third instance. So x1 is equal to 1 and x2 is equal to 0. And some unit is 0.4. So 0.4 is less than 0.5 value. Answer is equal to 0 only. So 0.5 is the threshold value. So 0.4 is less than 0.5 value. And if you have rounded this number, it becomes as a 0 comes out. So accuracy unit will return 0 in this time because the output of the sum unit is 0.5 and less than 0.5. So we not required to update any weights because of both are the same. Prediction value and active values are same. Now we'll go to fourth instance. Both are 1 and answer is called 0.8. And if you done this one, result is 1 comes out. So accuracy unit will return 1 because the output of the sum unit is 0.8 and it is greater than the threshold value 0.5. The active value should be also 1 as well. So both are same. The fourth instance is correct. Now 0.4 is the weight value. So will it work for the first one or not? First instance or not? You need to check it out. That's why you go for second round. So now we'll apply the 0.4 to this one. So x1 W1, x2 W2, x1 is 0, x2 0. Answer is coming also 0.4 is coming. So less than 0.5 threshold value is also 0. So all these things is working for everything. So the W1 is 0.4 and W2 is 0.4 is working for the and the truth table is. So we have applied feed forward calculation for the fourth and fourth instances, third and fourth instances already for the current weight problem in the previous ones. So they were classified correctly. This is the perceptron for the AND gate is. So the inputs and weights are 0.4 and 0.4. So Boolean you should take 0, 0, 0, 1 like this, 1, 0, 1, 1. And sum is doing like this. Threshold if greater than 0.5, the output comes into here now. Right? The output comes into here. Threshold value what you are taking 0.5 is the 0.5 is a value and is a taken considerations and we got the output like this way. So this is the perceptron for the AND gate.